Hi, everyone. I'm Jason Morgan, editor of Fleet Equipment, and welcome to Fleet Equipment Unscripted. Today, we're talking with Dr. Mihai Dorobantu, Director, Technology Planning and Government Affairs at Eaton Vehicle Group. Dr. Mihai, how are you doing? How's everything going on your side?
I'm good, Jason. I'm good, thank you. Like everybody, we're adapting to the new normal of working through COVID. So instead of meeting face to face and talking to groups and teams of people, we do this. And I've seen how your webinars have worked so far, and I'm actually pretty impressed at how both in your line of business and in general the way we do business, we have actually adapted to this remote communications.
Right. Now, it's true. First of all, thank you. That's very nice of you. I will have to PayPal your money for saying that here later. I appreciate the plug. But no, it is true. And I know we talked a little bit about it before we got started, just about how kind of taking the place of the travel. We both had traveled a lot, kind of missing that industry relationship, that collaboration and problem solving. So glad to have you take a few minutes to walk us through some of the developments in electric vehicle world right now. It was big. It was all we talked about pre-pandemic, and then the pandemic hit, and now I think the trucking industry in general is kind of in a survival type mode. So I wanted to just start off here, get your take on it of in working with customers and industry partners right now. What's the feeling around electric trucks? Is there still the enthusiasm for it? Are fleets still planning down the line, a year, 2 years from now, at adopting this technology? How have those conversations been going?
Well, so this is a good question, and it's really a mixed picture here. Obviously, COVID is taking its toll on development. You've mentioned the inability to travel, meet face to face, discuss and understand customers' perspective, partners' perspective, suppliers' perspective, firsthand, touching and feeling, if you wish, the equipment as it develops. That has changed radically. And at the beginning of the pandemic, we experienced significant shutdowns ourselves, our customers, our suppliers, the whole supply chain was disrupted in a major fashion. Right? It was came down to a grinding halt, and that includes labs and test facilities and the ability to build things up. I think we're past that, so the worst is over. We now have our technicians and our engineers in the labs, of course, with the new normal. So things have not gone back in the way we do business, but the outputs are still the same, and they're coming back online. So this was the headwind, significant headwind that happened and does affect the development of new technologies. The tailwind, I would say, is what's happening perhaps in the market. So we've seen a number of government actions. For example, the California Advanced Clean Truck regulation come into play. We've seen many states signing a memorandum of understanding to adopt that type of regulation. That has a significant impact in driving electrification of the commercial vehicles. So that is a good tailwind. But we're also seeing investments in infrastructure. We're seeing the I-5 charging corridor that is specifically designed and funded for charging freight or commercial vehicles, mostly aimed at freight. My job is global. I'm seeing similar things happening in Europe. So there is this expectation building into the market that so combination of regulatory funding, stimulus type of funding, and so forth, there's actually going to be at the end a net tailwind to electrification. And of course, the background of this is really sustainable policies that are coming either in the form of mandates, in the form of funding, in the form of customer pull. So all these things actually have not been changed by the pandemic, and if anything, are perhaps being accelerated now.
Okay.
That does create enthusiasm in the market. And we are not really seeing a slowdown other than the first couple of months of the pandemic in the work that we do with customers and with other government agencies and funding agencies and so forth. So I think we're coming out in good shape. The only way that I could perhaps say this better is that our demand for engineering time and resources far outstrips the supply that we have.
Okay, well, that's a good problem to have, right? That's always good. And I do kind of want to go in that for a moment too. Kind of take a product look here because you have done a lot of electric vehicle development, of course, in the heavy duty trucking world. Eaton, synonymous with transmissions and that technology. You've developed a 4-speed heavy duty transmission for electric vehicles. What were the initial challenges in developing that? What electric vehicles definitely have different needs, right? They operate differently. We've been in trucks that had kind of retrofitted transmissions, some that have other solutions. But on your end, in Eaton and bringing that transmission to market, what are some of those challenges? And then as you work through that, some of the standout features and opportunities that came from addressing that.
Well, so I can describe a little bit the journey that we went through, and it started about 6-7 years ago when the electrification, especially of commercial vehicles, was by no means a given, but it was really sort of the bus and coach segment was starting to look seriously at electrification, and at that time, in the passenger car development, electrification was looked upon as a massive simplification of the powertrain. Now the transmission's out. We only have one motor. The operator presses on the pedal, and the motor instantly and miraculously responds. And this is by and large true today. So that seemed to be the path to commercial vehicles as well. Being in that business, and you might even say that we're biased, we were at that point in time, the transmission was the absolute crown jewel of our vehicle business. So you might think that we're seeing, we're like a hammer, so everything looked like a nail for us. Everything needed a transmission. But we actually did take a look at some of the available electrical motors for buses, and those were huge motors. I mean, 700, 800 kilograms, so over 1,000 pounds motors, and they would barely deliver enough torque for a bus application, which in commercial vehicle space is one of the less demanding type of applications. So at that point in time, we realized that there probably are opportunities, but we had uncertainties on every front. There was an uncertainty in if the EV market will actually evolve. And that, of course, that uncertainty kind of puts into question investment. Should we spend our R&D resources into a market that might never develop? There was uncertainty if the transmission is needed. Will the motor technology sort of magically improve and those, hundreds or thousands of pounds motors suddenly reduce themselves to something very small and still maintain, high torque capabilities and so forth. We quickly answered those questions, but then there was the question of what's the right architecture. People were talking there about wheel-based motors. Those didn't really pan out, but their cousin, the axle based, the e-axle, is actually a viable technology. So we're thinking, is it really an e-axle? And we realize that for buses, that's really cool technology because their floor space is at a premium, and maybe for medium duty P&D packaging and delivery type of applications. But then they were looking at heavy duty, and we're recognizing that we're starting to recognize that the big societal drivers are still going to push towards heavy duty because that's where most of the fuel is burned. That's where electrification has the biggest environmental impact, which is driving everything. And we looked at that and we thought, well, not clear that e-axles are the right response for many reasons. And one of them being, for example, modularity. We realized that there's going to be a coexistence between diesel and heavy duty for a long while. So those were the initial uncertainties. We tried to resolve them. We started actually with the help of the Department of Energy. We actually posed the question, what are the optimal transmissions for different vehicle classes? And that is how we started. We got eventually into a 4-speed medium-duty transmission that we have launched. With that, we also did a market experiment with Proterra. We adapted quickly a 2-speed transmission. And that was not just a demonstration for proof of concept, that was a learning tool for us. So we thought that the multi-speed transmissions are going to just shrink the motor requirements because you can't make power, but you can make a lot of torque with a transmission. So extra torque is quote unquote for free. In the sense that all you need is a good transmission, whereas extra power you need more batteries, you need more electrical machines, very expensive proposition. And we see that some of the commercial vehicle applications today, they boast that they have 1,000 horsepower and they can go 0 to 60 in 5 seconds, but in the commercial vehicle space, that's not worth the money there. So we started realizing what the transmission ought to be. We did the 2-speed transmission with Proterra. That was a test bed. That's where we've learned what the transmissions do, but also what gaps and what other opportunities transmissions have. Baked in those lessons into the 4-speed, launched a medium-duty 4-speed, which had surprising results. For example, range improvements up to 20%. Where do those range improvements come from? Right? Because transmission at best has no losses. Of course, it has some losses, but at best has very little losses. So how can the range improve by 20%? Well, it turns out that with a multi-speed transmission, you can keep the brake regeneration at a maximum. And especially at lower speeds. So in applications like urban type of applications where there's a lot of low speed driving, that's where your electrical motor or generator in this situation would be driving at low speed, and that's where it is power limited. So you're leaving a lot of brake energy on the table, so to speak. Actually, you're putting it into the foundation brakes instead of regenerating it. And with a multi-speed transmission, you can drive the vehicle at low speed while keeping that generator at high speed, because you can control and change the ratios, and thereby recover almost all the energy. So these were things that we did not know at the beginning. It was because we did these market experiments, because I'm going to say we had the guts to try it when everybody told us there is no light in the transmission. You are only a hammer looking for your nails. But we've learned these things, and I think by now it is an accepted fact that in commercial vehicles you do need multi-speed transmissions. Almost everybody is doing that. I think there still are uncertainties. There's uncertainty in the motor technology. We're looking at high power motors that can go up to 16,000 RPM and things like that. Would you need 4-speed transmissions then? It's not a question of motor speed. It's really a question of the motor performance characteristics and how the torque curve versus the power curve look like, and how the efficiencies drop at the extremes of the mass. All these things are important. But what I want to say is that there's still uncertainty. So this process is by no means done. But we're proud that we have a medium-duty solution, we have a heavy-duty solution now, and we are seeing customer pull for both.
Right. Very cool. And as you point out, because I mean, I've gone through those conversations as well, of even from the fleet manager's point of view of the specking of the truck and how a lot of those decisions, it may seem simplified, but they're still going to come into play. As you mentioned, battery and power management is just huge. I mean, it trumps whatever you think that the truck should have or would have. It's okay. Well, how much can I get the range? How much charging want to do? Regenerative braking is great. And also what I loved is that I think that the journey you just described is probably a journey a lot of fleets are going through themselves, right? They're faced with uncertainty. They have questions. They have a role in it. But like yourselves, you took the risk and then you found your partners, right? And that was a big part of it. You didn't do it alone. So in having you go through this journey, what can you advise the end users, the fleets, on their role in the process? How can they help you help them with better products? Those kind of things.
Yeah. Okay. So this brings us almost full circle to your first question about how COVID is impacting the industry. And I was mentioning that we are expecting to see heightened activity in the deployment of and the pull for electrified vehicles. I think what's going to happen in the near future is that we're going to see a number of potential demonstration programs. And there are these tactics of sort of bridge type of applications where the value proposition is kind of obvious, and then that leads to adoption and so forth. There are a number of challenges and unknowns. Many of them have to do not so much with the vehicle itself, but with the charging infrastructure and the way these are operated. We have sort of two different scenarios in front of us. One is that organizations like ourselves, we assume that we know what the customers need, and we develop the solution and we bring it to the market, and then we kind of hope that the end customer will say, "Oh, what a wonderful thing you brought to us," and we're just going to adopt it and buy lots of it. But then there's the other approach, which is similar to the discussion that we had on the transmission side, but now thinking of the broader electrical components. As you mentioned, well, motor batteries are important, but the power management, the safety, the electrical safety, high voltage distribution, all the maintenance of these systems, the capital costs versus the operating cost part of the equation, all of these are in fact not known today. So the opportunity is to have these demonstration programs involving fleets up front. And I think that the fleets that will take the risk to sort of get involved into a demonstration program that has some risk in it are going to get a number of rewards. First of all, I think that there's an opportunity to leverage sort of public and private investment from their perspective to de-risk their investments or their commitments, so that they're not left, holding the bill or having to foot the bill for the entire operation without having some degree of certainty that it will actually be successful. But more importantly, I think that if they do participate in these kind of demonstration programs, they get to influence the technology. Just as we've learned from, working with Proterra, that strategy that I mentioned on transmission, the role of transmissions in upping the regeneration potential of the vehicle, which we would not have thought in the absence of that little market experiment. I think that's what fleets have a chance to do. The fleets that will embark in these demonstration programs will get an initial solution, but will get to sort of refine and specify how and shape how that solution really fits their operations. And those that don't participate will essentially have to accept in the market whatever the other folks spec out. So I think that is important for them, so that they get a chance and a word to specify or influence the technology. And the third thing is, I think the third advantage is that they can learn how they need to perhaps adapt their operation to take full advantage of the technology. So it's this give and take between I'm a fleet, these are my operations, I'm going to influence the technology to suit my operations, but oh, by the way, this technology offers me new opportunities. I'm going to change my operations to adapt and better get more value out of this. So I think that is the main instrument in which fleets can participate. And again, it's both the operation of the vehicle, the maintenance. Maintenance, yes, everybody thinks that the maintenance of the electrical vehicles is significantly simpler and more cost-effective and with more uptime than for the for their diesel counterparts. But what that specifically means, and am I going to be as an operator able to leverage that? I think that remains that still remains to be seen. And how do I actually leverage it? So the last thing to sort of realize is that the facility charging infrastructure for the fleets that are facility-based or garage-based, that is an open question. And in my experience, that is a harder problem than procuring the electrified vehicle itself.
Right.
So I think that's where the fleet opportunities are.
Right. I agree. I think you get that that real world look at what it takes to actually run the trucks, not just a conversation about range and battery life and all this kind of stuff. But I mean, it was even surprising to me. One OEM had an event earlier this year before all the pandemic stuff happened, and even the charging infrastructure discussion insofar as how software driven it is, right? Like if I have two different trucks with two different softwares and it doesn't match up to that charging station, the truck will, you can plug it in, but the truck with compatible software will charge. The other one won't, even though it's plugged in, because the software isn't talking. And I mean, you know, how often do we take for granted, like, oh yeah, just pull into the fuel depot and fill up on diesel. You don't even think about it, right? Now you have charging adapters and software where even when it's plugged in, hey, you know, you go to get that truck the next day and it did not charge, and it would not be fun to learn.
Right. Eaton is in this facility, the electrification of facilities business. I mean that is the bigger part of Eaton actually, and electrical vehicle charging infrastructure is a significant topic for us. And I think from this perspective, Eaton is uniquely positioned by providing both onboard chargers, which is what our e-mobility business does. You know, our e-mobility business really has evolved from the transmissions, EV transmissions that we talked about, and which were really based on the legacy of hybrid transmissions. That's almost a 15-year or 20-year legacy. But nowadays, it is really focused around power electronics and power safety and distribution. And part of the power electronics piece is really onboard charging, and that becomes that can quickly get really complex when the vehicles have to start communicating with the grid. You gave one example, but the other examples are if you have multiple vehicles, how do you match the charging demand with the actual electrical grid availability and cost structure and things like that. So that equation gets very complicated very quickly. And frankly speaking, most of our end customers, be they fleets, municipalities, school districts, and so forth, it's not their business to care about, the software on the chargers, for example, and the protection of the vehicles, or for that matter, how to design a distributed generation microgrid that also supports charging at the right time and helps their operations, doesn't disrupt their operations. So it's
sure. I think we could talk another hour on that, which I would love to do, but I don't want to keep you too long. I appreciate you taking the time. Thank you so much. Learned a lot, and I'm sure I will be bugging you again to dive into the infrastructure stuff, because that is,
Thank you.
I think that's worth its own conversation.
Thank you, Jason. I appreciate the opportunity. Thank you.
Take care.